Welcome back, physics fans. Here we go for forces. This is going to be one of our first full-fledged questions here. Physics 11. Oh, there's my clock again. Can you tell me what time it is? Two horses each pull a 1,500, I guess I got to put in there, kilograms. Snow sleigh with 400 newtons each. So each horse is pulling with 400 newtons. The sleigh is keeping a constant speed of 1.2 meters per second. So after that, then each of them starts pulling with 450 newtons. Okay. What is the frictional force that is constant? What is the new net force? What is the rate of acceleration after they increase? After 3 seconds, how fast is the sleigh traveling after they increase from 400 to 450? Then, if the horses were told not to pull anymore, how far will the sleigh travel before it comes to a stop? So let's just try to understand. Here we go. We have our sleigh, and the gravity is pulling down on it, and the earth is pushing back up on it. That's called the normal force. And the horses pull, and the frictions pull back. And there's all the forces on it. So the horses are pulling to the right here. The friction of the snow against the runners is pushing to the left. The force of the earth is pushing upward, and the force of gravity is pulling downward. So here is more of the question that we have, the one with two horses and a bigger sleigh because it's 1,500 kilograms with the people in it. So let's figure it out. A, what is the frictional force? Well, in our free body diagram, the normal is up, the force of gravity is down. There's two horse pulls, F horse 1, F horse 2, and then there's a frictional force. But we're told that it maintains a constant speed. That means the acceleration is 0. And therefore Newton's first law, as well as Newton's second law, says that the sum of the forces has to equal 0, because as long as there's a net force of 0, then it maintains its speed. Therefore, the frictional force must equal F horse 1 plus F horse 2, which is 400 newtons plus 400 newtons. So let's just push this down. Of course, interesting. A, I'll keep it as A, that's fine. Auto numbering is weird. F, force of friction is equal to 800 newtons. Then when they pull with 800, what is the new net force? I mean, when they pull with the 450 and 450. What is the new net force? So F net is going to equal the sum of the forces. And that is going to equal F horse 1 plus F horse 2 minus the force of friction, because the force of friction is pulling in the opposite direction. Okay, you can get that from our free body diagram, right? The normal, force of gravity, there's two forces of the horses, and then there's a frictional force. Each of these, sorry, there's my free body diagram. And that's fine. I haven't done anything wrong here, except for labeling it. There we go. But now each of these have turned to 450, but this is the constant force of 800. So this is going to be 450 plus 450 minus 800. Okay, so that's going to all equal, the new net force will be 100 newtons forward. Force of friction is always in the opposite opposing motion, so that'll be backward. C, or the new A, as it wants to renumber. Boom. No. C, what is the rate of acceleration? Here it gets a little bit difficult. Everything, a little bit more challenging. Not much, but now we're not just doing logic, which we could have solved from before. Rate of acceleration. Well, F net is equal to ma, Newton's second law. F net is 100 newtons. It's a 1,500 kilogram sleigh times the acceleration. So acceleration is going to be 100 divided by 1,500. So 100 divided by 1,500 is 0.06667, I'll keep 4 sig figs, meters per second squared, and that is forward. It would have to be forward because this force is forward, so it's going to be in the same direction as the net force. Okay. After 3 seconds, how fast will it be traveling? So we can go right to VF equals VI plus AT, and VI was 1.2 meters per second, plus A is 0.06667 meters per second squared, and it's now going to go for 3 seconds. So we take this number, multiply it by 3, and add 1.2. So this is going to equal 1.4 meters per second. Whoops. Forward. And that was, I guess, D, if I can do this. And then E, if the horses were told not to pull anymore, how far will the sleighs travel before it comes to a stop? So, in case you had to draw a free body diagram on this one, if it says draw a free body diagram, you would want to have the normal force, the force of gravity, and the frictional force. The velocity is this way, but it will be slowing down. Acceleration is this way. Notice I did that outside the free body diagram box. Yes, you're allowed to, but not inside. And then, therefore, the only direction of motion is this way. So the sum of the forces is going to be force of friction, and that has to equal ma. And that force of friction is still 800 newtons. And the sleigh is still 1,500 kilograms. So the new acceleration will be 800 over 1,500. 100 divided by 1500. And that's going to be 0.5333 meters per second squared, and the direction of that will be backwards. So that's the acceleration. That's important that we got it. Now, we want to know how far, the distance. Oops, can't lean on the keyboard while I type right, hey? Messes up. D is what we want to find out. We have the acceleration. We have the initial velocity, which is 1.4 meters per second. And that's to the right if you want. And we have the final velocity, which is 0, because it stopped. So the formula without time is going to be Vf squared equals Vi squared plus 2AD. Vf is 0. Vi is 1.4, and it's going to be squared, so it don't matter if we put negative and positive in there. Then it's going to be 2 times A, which is 0.5333, and I'm going to put that negative because I'm going to say this is positive, so this is going to be negative. So that's going to be a negative. And then it's just D. So I'm going to bring this 1.4 squared over to the other side, which will make it negative after I square it. So 1.4 squared. This is going to equal negative 1.96. And that's going to equal, I'm going to take these two numbers, multiplied together, and put it over the other side. And I'm going to divide by it. By dividing by this negative number, I'm going to be dividing by a negative number. So divide it by 2, and also divide it by this number, negative, and the two negatives make it positive. So this is going to be 1.8375 meters. And that'll be positive, which means forward. Okay, so once the horses stop pulling, the guy goes, whoa, and the horses stop pulling, the sleigh comes to a stop in less than 2 meters. Well, you're not going that fast, you're only going 1.4, but there we go. Dun, da, da, da. Thank you very much. Subscribe. Comment below, but I bet you can't comment below because I've been noticing that as soon as I say it's ready for kids, so you guys don't get advertisements, it turns off the commenting. Oh, that's YouTube. So like it, subscribe, and send me an email. Thank you.